Alright, hello class. Today this video is going to be very brief. It's going to be partly on old stuff, partly on new stuff. So we're talking about conics, and one of the conics that we haven't spent time on are circles. And as we can see, here's a circle, and this is the center, and the distance from the center to every point on the circle is always going to be the same distance. And the equation of the circle is going to reflect two important things: the center of the circle and the length of the radius. So here we have the equation of the circle. In this point, in this circle, the center is at 3, -2. So as we see here, it's x minus 3 quantity squared plus y minus -2 quantity squared, and it's going to equal 4 squared. Well, 4 is the distance from the center of the circle to any point on the circle. So that's how we write the general form of an equation of a circle. And if I want to make the circle bigger but keep the center the same, what do you see changing? But the right hand side, and based off the length of the radius. Okay, and if I want to change the center of the circle, I can do that too. I would just move the circle, and therefore the center now changes to a different point, and this point is negative. The center is -1.13, -0.13, which is right there. So your notes will reflect that same information. It gives you the vocabulary about the center and the radius. It gives you the standard equation if we know the center is at the origin, because life is easy. You don't have to worry about the h and the k. You know what it is 0, 0, and you have your answer. And here is the standard form of the equation. And if I suggest you draw a picture of a circle, and here is the center, and here is the length of the radius, and see how they react to the actual equation of the circle. So that was just a review of circles. Now we're going to move on to the general form of conic sections. Alright, so the notes on page 135 are very important. And if you remember, most of the functions that we dealt with on pages 109 had parent functions, those functions that all the equations could start off with or be described by. So all conic sections, even though they're different curves, they have a parent function. That parent function looks something like this, and this is called the general form. It's ax squared plus bx plus cy squared plus dx plus ey plus f is equal to 0. Now there are many different derivations of that, but this is a general form, and this is called the general form. And looking at this, you don't really know which type of conic section it will produce. Will it produce a parabola? Will it produce an ellipse, a circle, or a hyperbola? You don't know just by looking at it, but you can figure out based off the general form what type of conic section it will be, and that's based off of the portion that's called the discriminant. The discriminant is if I take my b squared minus 4ac. Well, what is b? Well, b is the number that's multiplied by the xy. A is the number that's multiplied by the x squared. C is the number that's multiplied by the y squared. So you calculate the discriminant, and based off the value, that will let you know what kind of conic section it is. And so on page 135, here are the notes. If b squared minus 4ac, i.e. the discriminant, is less than 0, and b is equal to 0, and a is equal to c, then you have a circle. If b squared minus 4ac is less than 0, and either b isn't equal to 0 or a isn't equal to c, then you have an ellipse. And if b squared minus 4ac is equal to 0, then you have a parabola. And if b squared minus 4ac is greater than 0, you have a hyperbola. Now if b equals 0, each of the conic sections is, each axis of the conic section is horizontal or vertical, which means the center is at 0. So over here on the bottom of the page, we have the standard forms of each of the different conic sections, and each of these standard forms can be transformed into the general form that's right here by simply doing some algebraic manipulation. So we're going to look at some examples on how to do that as well. So in this first example, we have, this is a relationship to a circle. They want you to graph the circle. And here we see that we have x plus 3 quantity squared and y minus 2 quantity squared is equal to 4. Well, that means that the vertex, since it's not x minus 3, that means that the x-coordinate of the vertex has to be -3, And since it's y minus 2, that means the y-coordinate of the vertex k has to be 2. So the center is at negative 3, 2 as we graphed it. And what's the radius of the circle? Well, some people would say, oh, the radius is 4 because the right-hand side is 4. But remember, the equation is r squared. So that means the radius squared is 4. So that means the radius would have to equal 2. So to quickly draw that shape, we just plot points that are 2 to the right, 2 to the left, 2 to the up, and 2 down from the center. And then we can connect those with the circle. And here are those points as well. So in here, this problem, we have classified the conic given by the equation 2x squared plus 2y squared minus 5x plus 3y minus c. So the first thing I would do is identify what A is, what B, C is. And as we say, A is 2, B is 2. A is 2, but B is 0 because there's no xy term. So that means if there's no xy term, B must be 0. C is 2. And D and E are negative 5 and 3 respectively. But in order to calculate the discriminant, all we need are A, B, and C. So since A is 2, B is 0, and C is 2, we calculate B squared minus 4AC, and we get a number that's negative 17. So since the discriminant is less than 0 and A is equal to C, then the conic is a circle. And in this example, they said the conic is a hyperbola. Well, I know you're wondering, how did they get that? Well, let's take a look. Here is the equation. A is 5. B, again, is still 0 because there's no xy term. C is 3. So then when I go ahead and calculate B squared minus 4AC, I'm going to get 0 minus 4 times 5 times negative 3. So 0 minus a negative 60 is a positive 60. And so because the discriminant is greater than 0, then the conic is a hyperbola since A is not equal to C. And that's it. That's it for the video.